Hello, everyone. Welcome. Thanks for joining our diagnostic training session today. And what you're about to see is a pre-recorded training session we did over in the United States. But be assured that a lot of the material that we cover is really applicable to any automotive application. So just be aware that yes, it is a lot of North American vehicles, but they will apply a lot of the same principles apply over in the UK as well. Now, if you do have any questions, if you're watching this during the premiere, you can just leave it in the chat. We'll be monitoring live chat. If you're watching this after the premiere, then just feel free to leave a comment underneath the video and we'll get to those as we can as well. So my name is Jason Gabrenas. I'm one of Snap-on's diagnostic technical trainers. I've been in the training department since 2013, traveling around North America, helping techs and shop owners get the most out of their diagnostic equipment. Before I did that, it was a couple years as a diagnostic sales rep at Snap-on. So I had 30 different franchisees I worked with, as well as the shops that they serviced in order to help everyone get the most out of their diagnostic needs. Then before I did that, it was 8 years at Subaru. So I worked in a dealership, and over time, I guess, just became the default diag guy in the shop. So I always ended up having the drivability problems, the intermittent problems, the weird wiring problems that would show up on those cars. And that's really where I cut my diagnostic teeth, was trying to figure out all those weird head scratcher type cars that would come into my bed. Then before that, bunch of other miscellaneous wrenching jobs. Been a little over 25 years under hood experience for me. So our topic today is hybrid vehicle diagnosis and testing. But in order to get through the diagnosis and testing, we need to first establish, well, what is a hybrid vehicle anyways? So generally speaking, a hybrid vehicle is going to be a vehicle that uses both electrical and gasoline engine in order to power the vehicle. So we're going to have the gasoline engine. We're going to have a large high voltage battery, and we're also going to have what we call a motor generator unit. It could be multiple motor generator units in the vehicle. Over in Europe, they call them e-machines. It's kind of the same thing. So it's an electric motor and a generator all in one. And that's going to help increase fuel economy because we can run it for a lot of vehicles anyways. We can run them in full electric mode for a while. We can run them in hybrid mode where we're running the electric and the gasoline engine, or just the gasoline engine. So the engine doesn't necessarily run the entire time, which increases fuel economy, of course. So let's talk about the different types of hybrid powertrains. There's three main powertrains that are out there that we see. First one's going to be a parallel. So that is the most common design out there. That's the one they use in, Toyota uses this. A bunch of other manufacturers use it, but it's the most common one. It's the one that's been around really the longest when it comes to hybrid powertrains. Gas and electric motors are linked to a common transmission. So we have the motor generator unit, we have the gasoline engine, and then they're linked with some planetary gear sets, a common transmission. The generator and the motor are generally grouped inside that transmission assembly as well. So it's kind of all one unit together. The least common system, they only have it on a few different vehicles, is going to be a series hybrid. So this is especially on like the BMW i3 Rex, I believe is what that one's called. So it's the electric BMW, and it has a range extender part of it. So it's all electric, but it has a gasoline engine that's attached to it as well. So the electric motor drives the vehicle, and the gas engine that's in it is only used to charge the high voltage battery. So that's kind of more of a more of an electric vehicle with an extra gasoline engine on it versus a true hybrid. And then we have the plug-in hybrids, which are becoming more common around the world. So gas and electric motors are linked to a common transmission once again. The generator and the motor are once again generally grouped into the transmission assembly. It's going to be a pretty close to what you would see on that series hybrid as well. But it just has a larger battery with a greater range. So a gas engine is used mainly under higher load conditions or low battery capacity. So for example, you plug it in, you get 100% on your battery, and then it drives around like an electric vehicle. If you're just going around town and getting groceries with it, so to say, you may never have that engine crank over and turn on. If you're just using it in electric mode, because we have regenerative braking, and if you just leave it plugged in, you're only going a few miles. That gas engine may never turn on, or it may only turn on when you're, say, going up a hill or something. So a lot of manufacturers have been going towards this plug-in hybrid. because it just makes it, gives it even more range and way better gas mileage. So different components that we'll see. So first off, what's going to be the battery, of course. So that's the main discussion point, the main driver for that electric engine. Battery cooling system, a generator, voltage converter, regenerative braking system it has as well, and the electric motor. And as we said, the motor and the generator oftentimes are all in one. We need to remember safety first. This is high voltage in here. Now, in the States, you don't necessarily even need any sort of certifications in order to work on hybrid vehicles, electric vehicles. But over in Europe, you sure do. There's a couple different levels that you need to be. But you want to be aware that there is high voltage in here. So positive and negative high voltage cables connected to a high voltage battery pack are controlled by 12-volt normally open relays. When the vehicle is shut off, the relays stop electricity flow from leaving the high voltage battery pack. So when the vehicle's off, the relays are open, and there shouldn't be anything flowing unless there's a problem with it. They are also insulated from the metal chassis, so there's no possible of electric shock when touching the metal chassis. They're isolated. A ground fault monitor continuously monitors for high voltage leakage to the metal chassis while the vehicle is running. If a malfunction is detected, the hybrid vehicle computer will illuminate the master warning light in the instrument cluster and indicate check hybrid system in the multi-information display. So it checks many, many times a second for shorts and ground faults in the system. If you've ever checked out, say, a Toyota, for example, Prius, you need that ready light in order to start driving down the road. So in order to get that ready light, the system does a self-test where it has to test. It tests shorts in the cables, shorts inside the battery, inside that battery pack. So if you get a ready light, you can be very confident that there are no shorts inside that battery pack, because it checks it all, and it checks it within 3/4 of a second in order to check and test. And then it continually tests to make sure there are no problems with the system. So very safe. You just need to be aware of it, and you need yourself to be very safe around it. There's special gloves to use. There's special tooling that you should use, especially high voltage meters that you should use in situations. So definitely outside of the scope of this class, but just be aware there's actually ASE certifications on these now, and there's 2 levels. You should at least go through that first level, I would say, just to be sure that you're aware of what you're dealing with if you want to get involved in these vehicles. And there are quite a few shops out there that have been working on these vehicles. You get your training on it, and it can be another good avenue to help fix your customers' cars, because there are a ton of them out there, and there's going to be even more over the coming years. We're going to see a lot of hybrid and a lot of electric vehicles coming down the road as well. So just make sure you're safe, especially when dealing with the battery. So the battery is high voltage, could be 300, 400 volts or more, depending on how the system is set up. It's going to be multiple smaller low voltage batteries that are linked in series to get this higher voltage. So most commonly, it's going to be nickel metal hydride or lithium ion batteries. Kind of depends on what the manufacturer decided to use for their formulation. The batteries will get hot. They need to be cooled in order to maximize the performance and the life and the charging of the battery. So it'll accept voltage to charge, and it'll also discharge more efficiently as long as it's around a set temperature range. So we don't want it too hot. We don't want it too cool either. So I live up northern New England here, or in New England, and it gets cold here. So when it gets too cold, you also need to heat that battery pack in order for it to be efficient. So passive air cooling is used. That's just, maybe I have some vents in the car, and it's just allowing the heat out as it drives down the road. It just blows outside air over it, which isn't all that great for doing what it needs to do, but at least it's something. Active air cooling, which would be like we see here, which would be a fan, like basically a blower motor that blows over the battery pack and gets that heat out of there. And then there's also liquid coolant. So some manufacturers use coolant flowing through there. It's special coolant. So in the example here, Chevy Volt uses DexCool 50/50 with deionized water. Now, why do I want to use deionized water? In case there is a short somewhere in the system. I don't want to be able to conduct electricity as well as non-deionized. Now, as we said here, also coolant is either warmed or chilled. So depending on what it needs to do, we got a coolant pump here and we have a coolant heater. So if it needs to heat it, it will. Otherwise, we also have a chiller here, which will cool it down. So it depends on what we need to do. If it's hot outside and the battery's getting hot, we need to cool it, of course. And if it's too cold outside, we need to heat it up, warm it up in order for it to operate at its best efficiency. So we're dealing with coolant pumps. We're dealing with, could be in some situations, could be a high voltage coolant pump as well in the system. So it just kind of depends on how the manufacturer has it laid out. Once again, everybody's a little bit different, but it does need to be heated. It does need to be cool. Needs to be at a good temperature, nice Goldilocks. So we also have the generators used by the engine to charge the battery. It's also used to start the engine. So it doesn't really have a traditional starter. It's going to use this generator kind of in reverse, locks up with a planetary gear set in order to crank the engine over. Also, this generator does output an AC voltage. So it needs to be converted to DC, which is where our converters and inverters come. So it could be an inverter converter, could be separate modules, depends on the vehicle. So it converts AC to DC and DC back. Steps up voltage from 200 volts to 500 volts for the electric motors. In the example of a Prius, they would do that. Also reverses that step up to charge the battery while braking. So it does a little bit of both. So here's the converter inverter here. We can see we got the electric generator and the electric motor. Those are AC 3-phase. And then we also have 200 volts here to the AC compressor. And we have 200 volts going back to the battery. So we got step up, step down conversion from DC to AC. The computer itself runs off of 12 volts. So we also have an auxiliary battery in there. So there's a lot of different electrical voltages and currents and types, DC and AC, running around in these cars as well. Oh, there it is. There's AC 3-phase right there. Also have a regenerative braking system. So it uses that electric motor as a brake. So it uses and then it uses that energy running as a brake in order to charge the battery. Now, it doesn't do a ton of charging. You're going to get just a little bit of charge every time. But as you're slowing down, perhaps just coasting, it'll do it. Also, when you're on the brakes and actually coming to a stop. Now, hydraulic brakes, of course, are still used on the vehicle. It's just they use it to supplement that electric motor being used to gather that energy and charge that. Also, the electric motor, like we said, motor generator unit most often does operate at a high DC voltage. It's used to drive the wheels, used to charge the battery during regenerative braking, like we just said. And most of these are a brushless type DC motor. So it still could be a 3-phase motor. If you've seen anything on like brushless fuel pumps, we're going to work in a very similar fashion. So let's talk power flow. So I had a hybrid rental just a couple weeks ago, and I thought it was really interesting how they had this display that would show you how the power was flowing throughout the system. So let's take a look at a couple of these screens that we might see on this. This is a Hyundai Ioniq, and actually it was a plug-in hybrid too. So you could have run off battery and the engine and the electric motor. So in this case, this is going to tell us when we're running in electric mode. This gives us a really good visual. Like I said, I think it's a really good visual. So we got the battery powering the electric motor, which then powers the wheels. So that's in full electric mode. That's where it might be just driving around town under light load. Could have just the engine running the wheels as well. So that's engine mode only. And then there's also a hybrid mode there where it runs engine and the electric motor to supplement each other in order to drive the vehicle down the road. We also have a couple different ways that we can charge the battery. So the engine can be driving the wheels while also charging the battery. Or we can be running the electric motor into the wheels while the engine charges the battery as well. So the engine does not connect to the wheels, but the electric motor is the thing driving the wheels, and that's charging the battery. Or we can also be running the engine to charge the battery and be doing regenerative braking at the same time in order to charge the battery. You can see how the flow is going backwards there. So that's under regenerative braking. Engine's charging the battery, regen's charging the battery. It's basically just filling up that battery. Look at that. Also charging, we can slow down the engine a bit when we do regenerative braking as well. Use it kind of as an engine brake. And then there's regenerative braking only with no engine operating. And then there's also, of course, an idle mode where I'm just maybe parked, nothing's going on. I'm not driving the wheels, the engine's not running, the battery's just kind of doing its thing, it's just sitting there. Or we can have idle charging where it's not driving the wheels. We can see the engine's not driving the wheels there. It is actually going and charging the battery. So if the battery gets to a certain state, the engine just kicks on and then it just charges the battery, even if the vehicle's not moving. And then we also have an engine braking mode where the wheels, the electric motor there is going to be using it as an engine, using the engine as a brake in order to do that as well, where it's not charging anything. The electric motor isn't driving anything. We're just using the engine, the gasoline engine, to slow the vehicle down. So a couple different flows. I just thought that was kind of a really interesting visual that the manufacturer gave us for that, to understand kind of how the power is flowing throughout the vehicles. I thought that was very interesting. Now we have a case study here with a 2008 Toyota Prius. This is thanks to Damian Coleman, who's one of our product managers over in Ireland. So he actually ran into this and used some of our tools to help figure it out. So the customer complaint was that intermittently the vehicle would not enter ready mode. And what did we say earlier about ready mode? The vehicle won't get into ready mode until it passes that self-test on startup. So that indicates there's probably a problem in the battery. Now, I also will say that a lot of the times you can diagnose this from the driver's seat. You can use data, you can use functional tests, basically understanding how the vehicle tests itself, because the vehicle does have a lot of checks and balances and tests itself. So we don't necessarily need to open many things up to dig for problems if we understand where the self-tests occur. And then we have the codes that it spit out as well. So hybrid control module, P3000 code, battery control system, and the high voltage battery control module had a code for P0AFA, hybrid battery system voltage low. So here's how the vehicle's set up. We have the inverter, we have the high voltage battery with the high voltage ECU, and we have these relays that we said run off at 12 volt. So they start up in a certain sequence, and this is also how the vehicle performs its self-check. It checks each of the legs as it starts up. So upon inspection, he found that the high voltage system would remain inactive as the high voltage contactors, so your system main relays 1, 2, and 3, were not being switched on by the high voltage control module. So SMR1, system main relay 1, is going to be the positive contactor. On the positive side, we see that. Number 2 is going to be on the pre-charge contactor, and number 3 is going to be on the negative contactor. So it has to go in a certain order. It turns them on in a certain order for a certain amount of time to check for shorts. So the pre-charge function is to limit the initial supply of current from the high voltage battery to the inverter. So we got a little resistor here. We do the pre-charge first, so we're not just rushing a ton of current from the high voltage battery to the inverter. And then this is how it would turn itself on. So ready on, it's going to be, you can see the different relay statuses in the chart. So stage 1, there's on, off, on. The next stage is going to be, we turn relay 3 on and turn relay 1 off. And then stage 3 is going to be all of them. And then the high voltage system's off. We can see the different stages there as well. So that's just kind of the logic that it goes through in order to turn everything on. So the battery on this vehicle is 14 blocks of 14.4 volt batteries. Each block is made of two 7.2 volt cells, which gives us a total voltage of 201.6 volts DC in this battery. Once again, we got to be careful of high voltage on here. Anything in orange is considered high voltage, so you want to make sure you don't get shocked or anything like that. Proper equipment, there's gloves, like I said, special tooling that you may need. Said also outside of the scope of this class, if you want to learn more, there are other classes out there that'll help you out, especially with these safety issues. But one main thing that we want to worry about is pulling that service plug out, which essentially disconnects it from the rest of the vehicle, so we don't have to worry about the battery discharging and giving us a shock somewhere. I know there's some shops they say, oh yeah, we do a lockout tag out with it. That kind of definitely a good idea. So we take that out and put it in your pocket, and that way you won't have to worry about anybody else finding it. Oh, why is this unplugged or whatever? So it's like a lockout tag out type thing that they do with lockout tags as well. So there's a service plug, and we can see down here 228 volts that we're hooked up to right there. So we want to make sure we pull that plug first and then check for voltage. So we want to check and make sure there is no voltage coming out of there before we go. Here's just a diagram of what the battery blocks look like. So it's a high voltage battery control module is right here. We have a high voltage cable going out of the battery there. We have our cells with a negative connection and a positive connection. So there's your negative connector there. There's a positive connector there. And as we said, we have these bus bars to combine them together. They also have individual sensing wires for each block. So the vehicle knows what's going on with that battery block. So this is just 3 of the blocks out of the many blocks that are inside the vehicle. And then also there's the control module here, the high voltage battery control module there, and the current clamp, which is right here. So that measures current going in and out of the battery on the negative wire. So you can see the current, how it measures there, and then that's the battery control module. When he pulled up data, remember how I said we can diagnose the vehicle, a lot of the things in the vehicle just from the driver's seat. We don't have to worry about it. So the first 2 graphs you can see are 2 of the different battery blocks that are there, and they're very erratic. They're not behaving like these other 2 that we see down here. These are getting a constant voltage supply going up, go from about 15 volts up to 16 volts. And on these 2 blocks, though, it's going positive to negative voltage. So I have negative 15 volts up to positive 16 volts. So it's swinging wildly on both sides. So that is obviously a problem. So they needed further investigation. So he decided to go back to the battery, pop the casing off, and come to find out a lot of those bus bars were corroded. So they removed them, cleaned them. Wiring and connections associated with the battery block sensing circuits were also inspected and cleaned. Apparently, this is a fairly common occurrence on these with between things just getting corroded with the copper. Conditions they are out on the road there, salt and chemicals on the road can certainly cause corrosion getting in there, with water intrusion or what have you. Still had a problem though, even after they did all that, still had the error. So they ended up unplugging the computer, and they found out these 3 pins right here were very corroded as well. So it needed a new computer. Now, apparently this is also a very common problem on Priuses as well. Water can just kind of get in, water intrusion somewhere, and then it'll wick down the wiring harness and get in here and then cause that corrosion. So 3 pins on the module were badly corroded. They replaced them. Once they did that and they got everything set up, this is going to be voltage for 4 of the battery blocks under a hard acceleration. It's going to result in a noticeable voltage drop. We see the voltage drops under hard acceleration there on all 4 of those blocks. All 14 blocks should return in a similar voltage under all conditions: full electric mode, hard acceleration, and regenerative braking. So all of the blocks should give us roughly the same voltage going up and down. And we'll actually see that. I have a capture from that Hyundai that I talked about. It's going to do very much the same thing. So we can actually go through data and see what the voltages were in between. So they should be roughly the same voltage. We want to see within a couple of tenths of each other. And they should all fall off at the same when I'm using it, and they should recharge at the same rate. They should be roughly the same across all the different battery packs. We call that balance. All right, so we can see, and then here's another one. This is under regenerative braking. So voltage increase in each block because it is regenerating the battery as we go. So the voltage should increase. Now the Prius has a similar type information display as the one we looked at before. So it's going to tell you helpful. It's going to be helpful for telling us what the fault may be or where the fault may be, just seeing how the voltage is flowing through the vehicle. So we got the vehicle off, we got electric only, we got just internal combustion engine operation, and then regenerative braking. So you could actually use that as you're driving to see how the voltage flow is going. While road testing the vehicle, we can also check the condition of the high voltage battery under certain operating conditions. During this test, we're looking for a difference of no greater than 0.3 of a volt between any of the battery blocks under load. So he actually went through and plugged this into a spreadsheet and figured out what the different values were, and they were all very close with there. And then state of charge as well. You can be, this can all be determined by data. By the way. It's all be determined by data. Battery pack current flow. I think this is interesting. So it goes negative to positive. So what that is as it's charging, the current's going to go one way. As it's discharging, the current will go the other way. So there actually is a relationship between those two. As the voltage kind of drops, the current is going to rise. So here's another example of that. So we can just see how the current kind of goes up, and then as the battery voltage goes down. And this is doing different tests, driving the vehicle under different conditions, and we can see how the battery blocks pretty much are fairly even. Also, the voltage and current relationship that we talked about earlier. So this is under regenerative braking in this case. So under regenerative braking, the voltage is going to go up, and then the current is actually going to go negative because it's charging the battery. And then as voltage goes down, as it's discharging the battery, the current sensing will go up on the data as well. So as I said, you can use functional tests, you can use data. Oftentimes you can do most of the testing from the driver's seat. And then when you actually have to physically inspect something, then you can do that. But you can at least know where to go if you understand how the vehicle is set up, how the power is flowing through there. And you can also look at the data stream to see how the battery is behaving. So let's go live on the tool, and we will see a few things that we can see. All right, so we got the tool up here, and I got the 2021 Hyundai Ioniq in here. So let's just pop in real quick and see a couple things that we could do with the vehicle. So of course we have our regular engine, because it does have a regular gas engine in it as well, of course. So system tests, maybe resetting adaptive values, VIN read and write. Might have to do some of that, replacing some modules. Functional tests. So a lot of functional tests in here, different injectors and so on. The usual stuff you would expect from an engine. Come down here, though, in order to get to the hybrid vehicle, we actually have a separate category just for that. So hybrid and electric vehicle. We have the battery management system, the hybrid electric control unit, the motor control unit, and the onboard charger. So that's since it's a plug-in hybrid, it will have the onboard charger as well. So in the battery management system, we can look at things like in data, which I'll show you a data recording here in a minute of a road test. But things like whether or not it has a fault, current going in and out, every single cell voltage in here. You see it goes down to, we got 72, and then there's some more down here as well. It gets up to 96 different cells in the battery. It's also interesting. It tells us, let me see if I can find it. Cell deviation voltage, so we know how far off they are between each other, which is good to know. If it gets over 0.3, we might have an issue. Drive motor speed, max cell voltage, and minimum cell voltage number. So it tells you what cell, in this case, this is just dummy data, so don't pay attention to that, but it'll tell you what cell has the maximum voltage, what cell has the minimum voltage, and then there's other PIDs in here for what that actually, here it is over here, what the actual maximum voltage is of the highest cell, and the minimum cell voltage for the lowest cell. So I can look through here. Like I said, we can do a lot of this from the driver's seat without actually having to physically take anything apart. We can get through a lot of the diagnosis without having to do that because the computer has a lot of that built in. As far as functional tests, fans, relays, so on and off, different main relays, on simultaneously, off simultaneously, onboard charger relays as well. All of that's in there. System tests. We can do an isolation breakdown detection function, so it can detect if there is a fault in the insulation. So you can go through that, you hit continue, and then it would tell you pass or fail, basically. State of charge calibration. So if I did any battery work, I would need to calibrate in the state of charge value for the battery management system to the state of charge value of the replaced main battery when replacing the high voltage battery. So when I replace the battery pack, I need to do this. So I just say yes, and it's a simple calibrates the state of charge to wherever the battery. Next one was the hybrid electric control unit. So data in there is going to be things like the 12 volts as well, ignition, battery management system readiness. Let's see, auxiliary battery current and voltage. So that's going to be on your 12 volt battery. You're going to have all of that, etc. So we have all of that information there. And then as far as functional tests, right? So engine clutch lockup, and then system tests. We have a LDC activation variant coding, which needs to be done when you replace the module, the hybrid electric module. You do have to do a variant coding in that, so that's available. A couple different engine on and engine off tests as well. And then if we come down here, we got the motor control unit. So these are things like electric water pump control. And then the last one is the onboard charger. So that's going to be as I said, the charging port from the outside of the vehicle. You need to do a variant coding on that module as well when you change it. So you can get all sorts of different codes and data from that. So with that, now let's go and look up the road tests that I have. So as far as this car is concerned, like I said, it was a rental car I had about a week or two ago. And I decided, well, I got to go get gas before I return it anyway. So I'll just throw the tool on and grab some data and see what it does, just driving the car down the road, right? Different settings. So of course you're going to have your pure electric, you're going to have your charging, you're going to have your brake brake recovery and so on. So I pulled one. This is out of the battery management computer. And we can see some things like, well, first right off the bat, state of charge of the battery. So you can see how it's slowly going down there. Whether or not there's faults, main relay statuses, battery current, you can see it goes positive and negative as it's charging and discharging the battery. You can see how that goes. Different temperatures. You go down here, you got battery max temperatures and minimum temperatures. Come down a little more. We got let me show the current already. Max cell voltage, right? So what's the highest voltage in there? It's not a huge range either. Max cell voltage number, so it'll tell you which cell has the highest voltage, minimum cell voltage, and which one has the minimum number. And if that was stuck at one cell for a long time, then that might be the one you need to be directed to. Let's see, auxiliary battery voltage. So that's a 12 volt battery, so 14 volts because the alternator's running. Let's see what else jumps out here. Just scroll down a little more. Cumulative charge current, cumulative discharge power. Let's see. Oh, so drive motor speed, right? So this is when the engine actually kicks on and off. So we have a generator speed, and then we have the engine speed, and then up here in this PID we have the engine start signal. So is the engine running or not? So yes, and then there's turns off, and there it turns on, and there it turns off, and there it turns on, and so on and so forth. So you can see how it's cycling the engine on and off there as well. So it gets interesting visually anyway. This is down here when we start getting into the battery cells themselves. So you can see as I scroll through them, they're all fairly even, and that's the way it should be. They're supposed to be even. Now, this is a 21, so it's a couple of years old. It didn't have terribly high mileage on it. I think it was like 30-something thousand miles on it. But you can see all the cells are charging and discharging at roughly the same rate. We can see that they're all fairly close within that couple of tenths of a volt of each other, right? So if one of them was performing differently than all the others, that might be indicating that we had a problem. Internal resistance in mega ohms, so 1 mega ohm there. Let's see, battery cell voltage deviation. So that even gives you a quantified number as a PID as to what the deviation is between the different cells, and we're only talking 0.04 at the most, so that's like almost nothing. But it does go down to that hundredths category. And if we come down here a little further, we get the rest of our battery cells here as well, and we can see how that works. And then whether or not the fans are doing what they're doing, whether or not they need to, different inlet temperatures, ambient temperatures, and so on, status of charge, etc. So you really gain a lot of knowledge as to what the vehicle is doing at the time. As you can see, like I said, charging and discharging the battery, you can see that reflected in the current. Max and minimum cell voltage reflects what cell has the maximum minimum problem. So we can do a lot of diagnosis from the driver's seat without even having to crack anything open. As long as you know where to look and what to look for, you can kind of understand where you need to go with that. So that is hybrids. And with that, that is our time here today. So make sure you tune in for new diagnostic content every week. We will be premiering a new video every Wednesday at 7 p.m. UK time. So make sure you check it out on the YouTube channel. If you're watching, well, of course, you would be watching this on YouTube, but make sure you subscribe, thumbs up, ring the little notification bell so you know anytime we post new content. And it's youtube.com/Snap-on Diagnostics UK. With that, time for questions. If you have any questions, just feel free. Once again, if you're watching this on a premiere, just leave it in the live chat and we'll answer those. Otherwise, leave a comment under the video and we will get to those as we monitor those comments as well. So I'd like to thank you for taking a little bit of time out of your day to learning a little bit more about how you might be able to be more efficient at diagnosing vehicles using some of the information that we've given you today. Hopefully, we'll see you next week. Hopefully, you can watch and see you on any of our other videos. Have a good week, have a good night, and take care.